All right, let's get right into it. Today, we're going to unpack the really complex story behind rare earths. Now, you know they're absolutely essential for our modern world, but as you're about to see, they come with a hidden and pretty significant cost.
Think about it. From the smartphone that's probably in your hand right now to the electric car you might be dreaming of, rare earth elements are, well, they're everywhere. They're the invisible, absolutely indispensable ingredients that are powering our high-tech lives. The key takeaway here is that our entire modern infrastructure really depends on them.
But you know, this isn't just about our consumer gadgets. Not at all. Rare earths are a huge deal when it comes to geopolitical strategy. They are vital components in some of the most advanced military technology out there. We're talking fighter jets, guided missiles, even night vision goggles. So this dual-use nature makes controlling the supply incredibly important. And this really puts things into perspective. The company we're focusing on today, Lynas, just signed a $96 million contract with the U.S. Department of Defense. A single deal like that just highlights how strategic these minerals are, and it puts a massive spotlight on the one processing plant we're about to take a closer look at.
So what are the actual consequences of this high-stakes industry? Well, processing rare earths, it isn't exactly a clean business. It creates a literal mountain of byproducts, which brings us to a single facility in Malaysia, where this whole problem is really coming to a head.
Okay, so this right here is the Lynas Advanced Materials Plant in Gebeng, Malaysia. You can see on the map these huge areas that are just needed to store the waste. We're going to focus on the spot that's storing something called water-leached purification residue, or WLP for short, because honestly, that's at the very center of all the controversy.
And the scale of this is just staggering. By 2028, it's projected that 2.1 million tons of radioactive WLP waste will be sitting right here at this site. That is a monumental amount of material that has to be managed and managed safely pretty much forever.
Now, I know this official flowchart looks complicated, but it shows something really simple. To get the valuable rare earths out, the process has to create these byproducts, the non-radioactive stuff and the radioactive WLP. This waste isn't some accident, it's a fundamental part of the chemistry.
So this brings us to the central conflict of the whole story. With literally millions of tons of radioactive material piling up, the big question becomes, just how safe is the storage? Let's take a look at the arguments from both sides, shall we?
So critics are raising a huge red flag about the location itself. The plant is built on peatland, which is, notoriously unstable and waterlogged. The groundwater is only about a meter below the surface, which means any leak could contaminate the local water table almost immediately.
But the official environmental impact assessment, the EIA, tells a very different story. It says that their computer models show a breach of the storage liner is highly unlikely. The report also points to a containment system and early warning monitors that are specifically designed to protect that groundwater.
But critics are pushing back on that containment system directly. They point to what they call standard practice, a thick plastic sheet, heavy clay, and they contrast that with the design used at the plant, a much thinner plastic sheet, a thin synthetic clay liner, and a layer of porous sandy silt.
And yet, the EIA's official position holds firm. It basically concludes that despite the specific materials used here, the system is adequate and it's designed to prevent contamination for its entire operational life. The concerns don't just stop underground, though. Another major point of contention is how these materials are handled in an open-air environment. Critics argue this creates a real risk of radioactive dust becoming airborne and spreading to the nearby communities. So, how does the official report address this? Well, the EIA details several measures, like continuous air monitoring for any emissions. It also points to a closed-loop system for liquids and a treatment process to make sure any discharged water meets really strict regulatory limits for radioactive materials.
Okay, so with this whole debate raging over current safety, what's the long-term plan? I mean, how do you deal with an ever-growing mountain of waste? Well, it turns out there is a proposed solution.
This is the multi-million-dollar question right at the heart of the company's future strategy. The plan is, frankly, ambitious, to transform a hazardous byproduct into something you can sell. But can it actually be done?
So the plan, at least in theory, is pretty elegant. Step 1. Remove the main radioactive element, thorium, right at the start of the process. Step 2. Doing this would make the remaining waste non-radioactive. And Step 3, sell this newly inert material as a commercial soil conditioner. Problem solved, right? Well, here's the catch, and believe me, it is a big one.
According to critics, this specific chemical process has never been successfully done at the massive industrial scale you'd need to handle the amount of material coming out of the Gebeng plant. So in their view, it's a huge gamble. The EIA report, though, frames this very differently. It doesn't call it a gamble. It calls it the result of extensive research and development. So it presents the plan as a viable path forward for reusing these byproducts, subject, of course, to getting that final regulatory approval.
So here's where it all comes together, right? You've got a geopolitically vital resource, a local community kind of caught in the middle, and a high-tech industrial process that comes with some very significant risks. And this whole situation forces us to ask a much larger question about the true price of our progress.
And this brings us to a direct comparison that critics have called a double standard. In Australia, the very same company operates under a zero wastewater rule and has to return radioactive waste to the mine it came from. But in Malaysia, treated wastewater gets discharged into the local environment, and that radioactive waste is stored permanently right there on site. And that leaves us with this final, really challenging question. The world's demand for rare earths is undeniable. It powers our green technology, it powers our national security, but this whole situation forces us to confront a pretty uncomfortable truth. When the world needs a resource this badly, who ultimately ends up paying the price?
The Environmental Impact Assessment Report is currently undergoing a mandatory public review process. The demand from the community is simple. Stop the expansion, remove the current radioactive waste, and return it to Australia. The Department of Environment is accepting formal submissions on this expansion now. You must submit your official objections before the closing deadline on May 24, 2026.